conversation. So, my name is Victoria. I'm one of the hosts of Fluidic podcast series, where we host discussions on the state of up and coming innovative technologies, new discoveries, challenges, and future development. So, following each one of our podcasts, we are going to release an issue into Fluidic Frontiers, which is our magazine with a focus on this upcoming issue being water. So today I'm joined by Nishana from Queen's University, who is pursuing her PhD in civil engineering with a focus on water distribution systems. So before I kind of give the floor over, I wanted to quickly go over to today's agenda. So first, we're going to have a presentation by Nishana on her research on investigating water quality degradation and how artificial intelligence can use degradation data to develop a proactive water management system, which will be followed by a Q&A where we will kind of uncover more about her work and about her. So, thank you so much for coming in, and let's bring the floor over to you then, okay?
Thanks for having me. I'm really honored to be here, and I've been following your podcast so far, and it's been really interesting. So I'm really glad to be able to share my work with you.
Yeah, thank you so much. We're really excited to hear about it. So I think everyone will be really interested in this presentation. I was really impressed when I saw it. So
today we're going to look at water quality degradation and how AI uses this data to develop a water management system. Now, delivering clean drinking water is a crucial aspect of water supply, but water quality is so vulnerable to deterioration as it travels through a distribution system. Now, although water is strictly managed and routinely monitored under regulation guidelines, treated water entering the distribution network can still contain microorganisms and contaminants. Trace amounts of metals are also found in the distribution system, either from source water or from residual from the treatment process, and even from pipe material releases. And these metals tend to accumulate on the walls of the pipes and other bacteria within the system. Now, coagulants used in treatment, mainly aluminum-based coagulants in Canada, often lead to residual carryover, which have recently been suspected to act as a sink for metal accumulation. And these accumulated contaminants, as well as biofilm in the network, are susceptible to release either through physical, chemical, or biological changes, as well as hydraulic disturbances. Well, what does this look like? Well, distribution systems are complex, dynamic bioreactors where pipe materials may corrode, they may form corrosion scales, bacteria also forms biofilm, and aluminum carryover forms deposits on the surface. Now, these deposits, these corrosion scales, biofilm, and aluminum may act as a sink, accumulating trace organic contaminants from the bulk water. Now, this pipe section shows water is flowing from left to right. So we can see water flowing from left to right. And treated water still contains nutrients, microorganisms, and bacteria. And once it enters into the pipe, they interact with each other, and they interact with the walls of the pipe components. And we could see microorganisms being deposited on the wall of the pipe, adding to loose deposits. There's also metal accumulation encrusting on the biofilm layer and other loose deposits. Now, biofilm layer acts as a protector for these microorganisms and accumulated metals or its complexes. And this can inhibit the effectiveness of disinfectants. Now, while we're still very uncertain about the mechanisms that occur in this distribution system, we do know that discoloration events triggered by changes in physical chemical parameters and high shear hydraulic events can suddenly mobilize metals from the walls of the pipes, and this can influence release and detachment in the system. And when contaminated layers detach, it can either redeposit further downstream or continue along the distribution system. And this could lead to degraded water quality and aesthetics. And when we as consumers turn our tap on, we see this colored water, and obviously this leads to increased customer complaints, right? But how do we know that this is what was happening? We decided to look at historical data from a Western municipality in Canada. We collected data from 2006 to 2022, and their distribution system has two treatment plants from two water sources, like snow melt and mountain runoff, and they employ an aluminum-based coagulant and flocculant. Their pipe material is mixed material, but it's mainly metallic, and their pipe age is about 28 years old, on average. And we use this historical data to do some statistical analysis to see what relationship, if any, existed that influence, water quality in their distribution systems. Now, in the work done on this municipality, we were able to identify that factors such as pipe material, pipe age, and size, as well as hydraulic conditions, drive metal accumulation in the water, contributing to degradation. We also found that significant correlations found between aluminum and manganese, iron, arsenic, and chromium in the distribution system indicated some kind of co-occurrence of metal complexes happening. But it also showed sink potential of aluminum, and this drives the mechanism of metal speciation in a distribution system over space and time. We also had significant correlations between aluminum and these metals led us to examine the role of residual carryover from aluminum-based coagulants that they employed, as well as we looked at the role of background aluminum along the and how this influenced metal accumulation along the network. We also, acknowledge that the sporadic behavior of these metals as they accumulate and remobilize along the plants can also be due to biofilm, which is known to act as a sink. Now, so here's what this looked like. The historical data, when analyzed over space and time, showed a positive, significant correlation between metal concentrations over season. So we had the 4 seasons, and we look at the trends over space and time from 2006 to 2022. And aluminum was found to be present in higher concentrations. If you can see the blue line, present in higher concentrations for all 4 seasons. And, this led us to suspect that carryover was occurring. And this aluminum was also found to have a positive, significant relationship with all parameters. This was observed for both treatment plants, for both plant 1 and plant 2. And a stronger correlation with aluminum and all metals of interest was particularly observed in the warmer months, in spring, summer, and autumn. And while the sporadic behavior of these metals varied for each season, it did indicate that accumulation and remobilization was occurring over time. This degradation or this remobilization of metals, what happens is when it is remobilized, it could, 1, accumulate further downstream, or 2, continue into your distribution system with the potential of entering into your premise plumbing. And this is what leads customer complaints of degraded quality or aesthetics. Now, when customer satisfaction is based directly on customers' perception of, sensory experiences, so let's say color, smell, and taste. When a customer perceives this as being diminished, it causes distrust in the utility company. The stakeholders are dissatisfied, disgruntled, and obviously it affects the municipality in several aspects.
I'm not sure if you mentioned, but is there like a specific reason why there's a correlation in the warmer months? Did you mention that, or?
Nutrition guidelines, you tend to dose more to combat higher turbidity. Think about snow melt, and even runoff of clouds, enter into the river. There's a lot more turbidity in the water. And so just operational guidelines increases the use of the coagulant that happens, right? So there's more carryover. Now, this is what we think is happening. We don't know the actual mechanism behind it. But just because of operational guidelines and things at the plant, that changes. There's also a lot of tannins in the water, so you have to combat those things. So there's a lot of things that drive the presence of these metals and accumulation occurring in those warmer months. So how does artificial intelligence come into play here? Well, we decided to use routine water quality data as well as customer complaints data as a monitoring tool for water degradation, which, if managed efficiently, can improve water quality, the supply, as well as consumer perception. Now, AI will be used to determine spatial and temporal relationships between water quality and customer complaints, which could help us identify what is causing this degradation. And this technique can be used to develop a framework to visually help in the implementation of feasible strategies for an effective water quality management system, and it should be adaptable to any municipality. But why customer complaints data? Well, customer complaints data is as close to real-time monitoring that we have. So it will serve kind of like an early warning sign for degradation in the distribution system. So by monitoring and analyzing customer complaints, utilities can identify trends and patterns that may suggest a particular issue along the network. So, for example, if you have multiple complaints about a foul taste or odor, this may indicate like a problem with probably disinfection or filtration. If you have like an earthy taste, it can often suggest maybe leakage along the pipe. The metallic taste probably is linked to some type of corrosion, you know? So if utilities companies are aware of the issues, they can take preventative measures before it becomes more widespread. Additionally, tracking customer complaints over time, utility companies can monitor the effectiveness of whatever remedial actions that they've taken and ensure that the problem is fully resolved. So just overall, the complaints, can be a valuable tool for addressing water quality issues in a timely manner, and it ensures customer satisfaction. But machine learning, particularly neural networks, can be a powerful tool in the analysis of water quality in a distribution system, particularly for visualization, because they can identify significant correlations over large spatial and temporal data sets. They can account for sparse data sets as well. Now, while other methods can be used, neural network is a more effective tool for visually understanding this fact. And you're able to, see the processes that drives this degradation, and it can be used for discoloration events, leak detection, and it can even, indicate hotspots for degradation over time in different areas. And this allows us to be able to develop an effective water management system so stakeholders or decision makers, both technical and non-technical, can visualize the strengths of this trend and make informed decision based on these corresponding influencing parameters. So this beauty here is this is what it looks like, right? Now in these maps, the black denotes low levels or low values, while the yellow denotes high value. So how do we interpret these things? Well, this is where the fun part is. We have to identify common patterns at the same physical location within different components and label planes. So this indicates like what correlations are available between the variants. So for example, this aluminum graph, you see the red and yellow cluster in the bottom left corner of this aluminum graph. And now, if we compare it to another variable with similar output, this indicates that a correlation is occurring. So in this case, we can see manganese here. There's a red and yellow cluster in generally the same location, which confirms what we know, that there's a correlation. A correlation exists between aluminum and manganese. Now, similarly, for arsenic, there's a bit of red and yellow happening underneath here. We do know that some kind of correlation is probably occurring between arsenic, manganese, and aluminum. It may not be as strong, but we see some kind of correlation taking place. Similarly for chromium, the clusters of chromium indeed more correlates to manganese than it does for any of the others. And we do know from the old school method, which is Pearson correlation method, either through SPSS or Excel or one of those, one of those tools, that there was a correlation from the data that we analyzed. Now, likewise, for iron, we see general color clustering occurring, which we can see in a similar location for arsenic, manganese, and aluminum to some extent. So basically, the correlated variables having these colors in generally the same location, right? Now, in this way, these plots can be used to identify and locate a variety of behavior related to discoloration or factors influencing customer complaints. So we can use this visualization tool to show trends over time. Now, because of the nature of this is area specific. So picture a heat map of a municipality where you can see the factors that affect degradation the most. And it's interesting because for a non-technical person, you could just pull this up and say, oh, in this village A, there's a lot of iron problems. And so we know to focus on iron to, do some type of preventative measure. And over time, you become proactive as opposed to reactive for customer complaints and for degraded quality, right? So this AI method is what can help with water management systems for any sector in any municipality in any country, especially for non-technical decision makers, because a lot of managers tend to be not engineers, so it helps non-technical decision makers. Now, as with anything, there's limitations of the tool. One of the limitations is there's too few data set. If you don't have enough data set, then you won't be able to do the iteration. It does require training the data, and it does not create one model. So basically, it's not a one size fits all. It's site specific, right? So you just have to train it. Requires some time to train the data. So the preparation time is a little longer than if you had to just run an Excel sheet or run something on SPSS or one of those. And also, I mean, color interpretation is subjective. I might see a trend, you may not see a trend. The decision maker or policy maker may not see a trend. So the color interpretation is very subjective. Now, how can we use AI in water management? Well, data-driven analysis techniques provide insight into the dominant mechanism that is influencing contaminant release and discoloration on customer complaints for each location. Now, this neural network can work with other municipalities to help their management system in Canada, in Caribbean, and small island development states, which is where I'm from, Trinidad and Tobago, to improve their water management system. And it helps us tackle issues they may have with degradation, whether it's metal or biofilm, a lot of discoloration or leak detection. You know, a lot of time, a lot of countries have intermittent supply. So you tend to find most countries have an intermittent supply. And, you know, other than accumulation, there's a lot of release happening because this internal layer of the pipe dries during this period of drought. And so then when water comes in and the hydraulic changes happen in the pipe, there's a lot of release happening. So you tend to find those people having more complaints of discoloration in their pipe as opposed to somebody who have constant supply. And yeah, like AI, this tool is relatively affordable, it's readily available, and it allows us to continue to do our due diligence towards Sustainable Development Goal 6, which is clean and safe drinking water for all. So, I mean, you know, have any questions? Like, just let me know.
Yeah. Thank you so much. That was a really great presentation. You actually are very good at explaining everything very clearly, and as you said, like this research can almost be like easily accessible for those. That's what the point of it is essentially, and I think that's amazing. Really kind of bridges the gap between being able to improve our water quality if it's easily accessible essentially. That's really great. Yeah. I would love to ask you some questions. Pardon me?
So that's the goal, to improve the water system, improve water quality everywhere.
Yes, most definitely. But yeah, I can definitely ask you some questions based on it then. So, I mean, one of my first, I'll have some questions about kind of the presentation and some questions about almost you yourself. Essentially, maybe a couple questions that I have is essentially kind of your background essentially is that you worked in water quality management, essentially, not in Canada. So you actually have a wide range of experience in it. And I just wanted to kind of know almost a bit about kind of your industry experience and how that kind of translated to you doing a research project on it, and kind of what was the value almost from, having a position doing that for I think it said 4 or 5 years, right? So you have a lot of experience in water quality. So yeah, just talk about that.
So before I came to grad school, I used to be a water quality supervisor at the Water and Sewage Authority in Trinidad and Tobago. And I also worked as a water specialist, research consultant with the Policy Development Center in Barbados, and we did some work in St. Lucia. But I also did some observing and training with Utilities Kingston before I actually came to grad school. And so that's when I met my supervisor, Dr. Stuart Jean Payne and Eve Billion, in a professional capacity, actually. And one of the things that Trinidad and Tobago struggles with is degraded water quality. And because of infrastructure, intermittent supply, and all these things, you always wonder why people complain about poor water quality. What is being done? Is it the infrastructure? What can we do to fix it? And when the opportunity arose for me to do research, I was really interested in the work that Dr. Payne and Philion was doing. And I saw it as a chance to investigate all the questions that I had, but also as a chance to what I contribute when I'm done, like how can we improve the water management system? And yeah, I mean, like I was exposed from like water summer school I went to in Poland, and we did a lot of technology, even seeing new technological advances when I attended Singapore International Water Week in 2016. I was already employed at the water company. I think I started in 2015, I think. Um, but yeah, like just seeing all these advances and thinking to myself, wow, like um, there's so much to learn, there's so much to discover, there's so many new things. And I think having come to grad school, having done the research, I have a greater appreciation of the findings. I could understand the influence and parameters, but also I could understand sometimes how it's difficult to treat with something. Because, a lot of people tend to look at research as, yeah, it's a blank canvas. And you do research, you're hoping to find something, but you don't really know what you're going to find, right? Like a PhD is trial and error. You don't really know if you're going to find anything, maybe, maybe not. But I mean, like you're hopeful and being able to do research and formulate a research plan based on what you know occurs in the distribution system and going into this with an unbiased mind. Because you have to approach something unbiased. Like, I feel like being able to do that, but have an industrial experience allows me um, to see what was going wrong, like why these things were happening, and it allows me to, help design this water management system that I think could be adaptable in any municipality, and particularly could be adaptable in those regions that could help improve water quality.
Yeah, yeah. So it's almost like a passion project of yours to be able to almost like bring this back to where you were working.
I feel like it is because you know what? I think in March 2023, my supervisors and I, Philip and I, and also a colleague of mine, Alan Lucas, who was an engineer at Utilities Kingston, we did a paper on leak detection and monitoring water loss in Trinidad and in the Caribbean. We use AI. We use AI as well to develop this system. So I'm hopeful that the research is going in the right direction and it would reach the right decision makers, and it could be useful.
That's great. Oh, very interesting. That's amazing. I mean, another question I had, though, I think you briefly touched on it, but from going to working in water, kind of as a water treatment specialist and such, I'm sure you didn't. I'm not sure though. But tell me kind of a bit about your background using almost like artificial intelligence and stuff like this. Is this something that you've really had to learn for this project? I know you said you heard about it at a conference or such, but was this something that when you heard, you said, "Oh my gosh, instantly, this is the project I want to do," or was it almost like how were you inspired to almost start using artificial intelligence as opposed to kind of more traditional methods, which would be actually water quality management, as I spoke with in a previous interview with Dr. Yves Filion, which is he's doing a whole modeling, right, of water management, but this is an AI model, so it's almost quite different.
So, guy, and he'll be my supervisor. He approached and said, like, I want to look at this. Like, we could use technology to do this, and we didn't really customer complaints space. We thought about environmental and operational guidelines, but then when like over time, I guess we realized that customer complaints is as close to real-time monitoring as you can get. Like in situ monitoring is hard, but customer complaints is and it was really his idea to use AI because he's the modeling guy. Like he suggested we did AI, and I had done some work with like statistical analysis. I kind of do a lot of work with statistical analysis.
Of course.
It also happened because when I came to grad school, COVID happened and I couldn't go to the lab.
So true.
So I just started doing statistical analysis. Hence, all this work that we've done. But I had to learn these neural networks, and I had to learn some machine learning. And I think that's the most rewarding thing. I haven't invested that time learning all these programs and software and seeing it come to fruition, like seeing the results, seeing the things that you produce. And then it's being recognized amongst your colleagues and your peers, like, as well as with experts and these amazing people in the field. Like, I mean, it's really interesting and exciting to see, especially because everything now is AI. We're using AI in
It
everything.
is. Everything is.
Yeah, so for us to be able to use this in our field and to have such amazing acceptance and feedback and just action on it, it feels amazing, you know?
Yeah, yeah.
Yeah, and it has a lot of traction. So, I mean, that's a good thing.
Most definitely. I mean, a question that essentially I have for you as well is a bit more related to your research. I'm sure you always get this question, but what are definitely like some of the biggest challenges in your research, and then obstacles or challenges you faced like personally? I mean, I can imagine that like a project almost based on like customer complaints is based on essentially like the amount of complaints. Is there an issue with that, or in certain regions do people not complain as much? I don't know. So you tell me, what are some issues that you've kind of faced?
Okay.
Is it because it's subjective?
All right, let me start from the top then. Some positives about my research is that I love working with my supervisors or ideas. They really push you to do it. You want to do it. Like I know a lot of people are tired of grad school, far from there, and I hope that doesn't stop me from trying to. But some challenges I've faced in the lab would be maybe like not getting the results that I thought I would get.
Yeah.
But my supervisors have a good mindset in that they tell you no results are still results. So I struggled with that mentally initially in the first part of my lab experiment, having understood that and accepted no results are still results. Like it put me in a better place. So it was no longer a struggle. If I go to the lab and something works, it works. If it does not, it's still something that I'm going to use to publish. It's still, so the other part of the question is,
I was just saying, what are some issues or some obstacles or
personal issues
you've had specifically this project?
Okay, so I mean, my laptop is only as strong as it would allow to do. And I remember the data set at one point we were running iterations, and I was using like a stratified random sample of this customer complaint because it's like millions and millions of data set. And my computer would be running this iteration for like months. It didn't have the capacity to run the data set. So then Dr. Filian, we bought computer on steroids, I call it. And desktop computer, and we were able to analyze the data set because there was so much data from 2006 to 2022. But that allows us to have a better hold on predicting these hotspots for degradation, and I think in that sense it will be able to give us a more effective management plan. So in that way, that system that we develop that the municipality develops could be more efficient and effective. So there's pros and cons. Like, your computer, you can't use it for like a while. But then when you do actually get it done and the iterations have been run, like it works.
Okay. Yeah, makes sense. Obviously, working with such large data sets.
Large data set, yeah. I mean, like people do complain. I'm sure there are people who don't, but generally, as I said earlier, like customers' perception are based directly on their sensory experience. So what they see, what they smell, what they taste. And if you open your tap and see the water looking slightly discolored, not even discolored, like people in third world countries would have, just slightly discolored, you would be like, I'm not drinking this. I'm drinking bottled water.
Yeah,
No?
definitely.
And drinking bottled water is recommended in a lot of places.
It is,
boiled water, bottled water. Even if you go travel to some destinations, there'll be a travel advisory that you should drink bottled water.
Definitely.
As opposed to like tap water. But I mean, it's because of sensory experience. Like it looks a certain way, it smells a certain way, and really and truly, the water leaving a treatment plant from experience, because I know this, it's always within spec. It's always within guidelines. A water treatment plant won't release water that is not within spec. Right? And Canada has some of the strictest guidelines, like the turbidity is less than 1, all those things. Whereas if you follow, so Health Canada, I think the turbidity is less than 1, as opposed to if you follow AWWA guidelines, the turbidity is less than 5, right? So, I mean, like the average person can't see the difference between 1 and 5.
No.
Or like if the turbidity, if the color is like 15 or 20, you could start seeing like a tinge of brown. But just picture people who open their taps and the water is really brown, it's really dirty, they don't want to drink it. Or even washing white clothes, their clothes become dingy, like, you know. So people complain, like, why am I paying for a service and the water quality is bad? You know? So it's a reliable data set to use in the first place. You know what I mean? It's really reliable because people just don't want to be able, they don't want to pay for something if they're not getting good quality.
Yeah.
You know?
Yeah. No, it's definitely true. I mean, I only ever experienced that in Hamilton. Right. The water would be off.
You know, Canadians
It's not
are
in
really
Toronto, but in
fortunate.
Hamilton. Pardon me?
Canadians are really fortunate to not have to experience
We are.
a lot of the water quality issues that many other parts of the world
100%.
especially intermittent supply. Like I tell when I take Civil 272, like water, wastewater engineering, or any of the courses actually, anything I have to present, that I say Canadians are really fortunate to have constant supply of drinking water.
For sure.
Don't take that for granted. Don't take that for granted because a lot of countries have intermittent supply. And that intermittent supply also contributes to degradation of this aesthetics in the world. You know, so where people think that, the water in this country is bad, don't drink it. It's not the water leaving the treatment plant is bad. It's the water that's being transported like along that network, that distribution network is where the problem comes in. But obviously the water company gets the bad name. Utility companies get the bad name as opposed to, the distribution network.
No, we are very fortunate to essentially be able to drink water from our taps, and we actually are, seriously. I really do think about that, so definitely. I mean, I just wanted to almost like switch gears a little bit and talk a bit more about, something that, obviously is also, something that you're very passionate about water quality, also passionate about teaching. Obviously, you have a lot of experience. You've been a TA. You've told me that you've designed courses and such. You've been an instructor for STEM and such. So kind of tell us a bit about your experience doing that, and then also kind of how some of that experience has, contributed to becoming almost a better researcher, essentially, or a better, basically developing better projects, or your project right now.
I think that my experience to be in academia, be in this teaching field stems from the fact that I had really good role models growing up. And a lot of my role models were like teachers in that aspect. So they have always had a great impact on me. For some reason, right? They've always believed in me, they've always motivated me to do these things. And now being in academia, I take passion in like seeing aha moments in students. Like, you wanna motivate them to do well. You wanna motivate them to be their best, but also like we need people in STEM. We need girls in STEM. We just everybody in STEM. And so I take a lot of pride and passion in being able to be an ambassador for education and children, whether small children or older children. Like I give back to my alma mater back in Trinidad, where just promoting children, education and children, and having them know that education is one thing nobody can take from you, but to be able to reach a point where you are contributing to the change in something, it's leaving it's leaving something behind. Like you're making the world a better place just by being in it. And I love teaching. I've been doing it I started as a TA back in Trinidad, back in the University of the West Indies, where I did mathematics for scientists. I think was the first thing I taught with Dr. Legal. And like I came to Queens and came to teach chemistry for civil engineers, water and wastewater engineering, redesigning all these labs to kind of bridge the gap that happened in COVID, because a lot of at-home labs students didn't have the skill set that we expected them to have, or we would hope they have. And the only thing we could have done was design a course that allows them to have this hands-on training to bring them up to speed. And I mean, it's been well received, yes, but it's not the end. Like you do have grad students come into grad school with little or no experience. I mean, like I'm fortunate to come from the industry that I had experience working with certain equipment, so I think it kind of put me at an advantage. But what what I'm really happy about and proud of is that I took that advantage to share it with others. You know,
Yeah.
like what's the sense of having knowledge if you can't impart it on others? So
Yeah.
like
Yeah.
that's just my driving force to help people be their best. You know.
Yeah. Yeah.
And as I said, like I love seeing students have like this eureka moment or this aha moment, like
Yeah.
yes, like STEM is fun. STEM is all about life. Like just we're waiting for you.
Yeah, definitely. I mean, your passion definitely shows, and even the fact that what are you doing right now? You're teaching your research to like a public, right? So it's almost like there you go, you're teaching it, right? So and sharing your knowledge, right? So I can definitely see how much you value it and how good you are at teaching, essentially.
Thank you.
But yeah, of course. So I mean, I don't really have many more questions, essentially based on your project or anything. If there's anything else, I mean, maybe we can talk a little bit about, we talked a bit about it, but even just a bit about how you see, like you kind of mentioned that you see your project being able to essentially like impact water quality management, give better tools essentially to decision makers, and that, not just trained professionals can see this data. Where else do you kind of see this going, or essentially like what are other future directions of kind of your project? Or would you want to trial this somewhere? Is that your kind of hope that this will be almost trial?
I mean, basically, this is trial. Like this work is from real data.
It is from real data, but using this.
And so this is what we're doing. Like we're developing this management system for them.
Yeah.
And so this is how we know it's adaptable, right?
Okay, good.
I mean, the world is going in an AI direction. Like everything is AI. And so if it could be used for customer complaints, it could be used for leak detection, water loss, but any aspect of water management, not just discoloration, not just customer complaints, like just every aspect that you could think of. From treatment, from background, source water, groundwater, like just anything you could think about. It's applicable, it's adaptable. The only thing you need to do is train the data or like just create the model. It's not a one size fits all because not everybody complains are the same or not everybody's operational guidelines are the same. Like it varies at plants and based on source water and all these things. Because some people use river water, some people use snowmelt, some people use groundwater, desalination water. So those things are different, right? So it needs to be tailored for each place per location. But just picture how perfect this would be. Obviously not gonna happen, but like just picture it. In time to come, like there would be an area where you could just look at this and say, based on the data, we predict that in 5 years, they're gonna have high iron and manganese problems in this water. People are gonna start complaining about the metallic taste, maybe from corrosion, and we need to repair the pipes or do some type of preventative measures so that doesn't happen. And so you do this preventative maintenance work in 4.5 years. And maybe it reduces the amount of complaints you get, and then you say, okay, so maybe it wasn't 4.5, but it was 4. And so then you do 4 years, and then you realize that instead of being reactive, you become proactive. You know? So I mean, people start having a little more faith in water utility companies. People aren't disgruntled about paying the fees. Because you tend to find that a lot. Like, I'm paying this amount of money, I don't have water in my taps, or the water quality is bad, there's too much chlorine, there's too much, So I think that with anything, this is definitely the future of water management systems.
Yeah, no, I definitely believe the proactive angle is the best. Absolutely. And it's almost like AI is almost like telling into the future. It's like almost like, you know what I mean?
It's in hotspots for degradation. Like it's going to tell you this degradation is going to happen at this point. So like be prepared, and we're able to take preventative measures.
Yeah. That's amazing. Wow. That's very interesting. But yeah. I mean, essentially that's all I have today. I really want to thank you for giving your presentation.
Thank you for having me. I'm really excited to have shared my work and my experiences with you guys. And
Yeah.
hopefully we'll be seeing more of AI being used in the water sector.
Yeah, exactly. You're one of the pioneers right now of it, so that's pretty exciting.
Dr. Fillion and Dr. Bean, it's
Dr.
all
Fillion, of course.
good and bad,
right.
good and bad.
Yes,
I say that,
yes.
like everything good and bad that's happened is my supervisors.
Yeah. Oh, nice. Well, yeah. Well, thank you so much. Really
So
looking
much for
forward
having
to hearing, how everyone reacts to this. And yeah, thank you so much for coming in. It's been a pleasure. Thank you so much. Your enthusiasm has been really, really nice to speak about it. So thank you so much.
Thank you.